Okay, everybody, this is chapter 7, section 1. We're dealing with exponents, and exponents are sometimes referred to as powers. They're just a way to kind of rewrite a math problem. We'll talk about some different things that kind of make exponents. There's a lot of different rules that go with them, so we'll learn how to kind of wade through the differences and how they're written and what you need to do with them. Okay, so really important you learn all these rules as we go through this chapter. There's lots of little different ones we gotta make sure we understand. Okay, all right, so let's start off with our definitions. Once again, if I start going a little too fast, just hit pause, get your notes caught up, and then get back with us and we can get going. Okay, so this first one is zero exponent. Every non-zero number raised to the power of 0 is 1. And so when you see this word power, I want you to also think of the word exponent. They're kind of interchangeable. And what we do is we take a number and we can raise it by different powers or different values of an exponent. But this one first definition is kind of a unique one. So if I had something like 5 and I gave it an exponent of 0 or a power of 0, the definition of that is whenever there's an exponent of 0, my answer is just plain old 1. Okay? So taking that rule, I can apply it to lots of different things. So another one would be if I had something like a -4, but it's to the 0 power, its value is also 1. Okay, and there's a thing, if you ever got into calculus, that explanation of why that is would be part of what you did in calculus. Obviously, we're not there. And if I try to explain to you, one, I'd probably mess it up, and two, it probably wouldn't make a whole lot of sense to a lot of us. So we'll just take it as this is a rule, and I apply it all the time. And just to kind of extend it, if I had something like a variable to the 0 power, okay? Now a variable actually represents a number. What it is, we don't know, but it is a number. And so basically, if I raise that to a 0 power, it's also going to be 1. Okay? All right. So there you go there. Another rule that this one's very important. This one comes up much more and more relevant to what we're going to do. So if you have something to a negative exponent, it's going to tell us to switch the location of that base and make the exponent positive. Okay, so that's a pretty basic one here. We might kind of change some of the wording here to make it a little bit more understandable. Okay. Okay. The word base is kind of a unique one for us, but we're going to use it a lot in this chapter. A base is just a number. Okay, so like if I went back up to these examples I did before, a base is this 5, or a base is that -4, or the base is that x. Okay, so the base could be a lot of different things. But the base is what we raise something by a power to, or we give it a power of 0 and then it becomes 1. Okay? But if I have a negative exponent, mathematically I can't have that, because what it's telling me is to multiply something by a certain number of times. Well, we can't do that when it's a negative number. So I have to make it positive. When we have the word switch, I like to think of the word flip, because every number can be written as a fraction. And so really what I'm going to do is flip fractions. And when I do that, it makes the exponent become positive if it's negative. Okay? So we'll kind of play with that as we go along here. But this is a big rule right here. You got to make sure you have that and know how to play with it, okay? So if you got these different examples here, I know there's a lot, and if you want to hit pause and write these down into your notes, that'd be fine. and just hit play once you get it done. Then we'll start going through the solutions here, okay? And then I'm just going to start doing them. So when you have something like 2 to the third, it really means I'm taking that base, which is 2, and I'm going to multiply it to itself however many times the power is, okay, or the exponent. So really it's telling me to write it out as 2 times 2 times 2, which is not 6, okay? That's what we got to make sure we understand. It doesn't say go 2 times 3, it gives me 6. It says 2 times 2 times 2. Well, 2 times 2 is 4, times this last 2 gives me 8. Okay, so we need to make sure that we understand, what that really means. Okay. So we go down this one down below, 2 to the second power just means, 2 times 2, which in this case is 4. But don't let that kind of fool you, thinking, okay, I can just multiply the base to the exponent, I get my answer. This is really, that example right there is a clue that we have to be very careful with it, okay? 2 to the first power just means I have 2. But, we don't write numbers with an exponent of 1. But we need to, as we go along, we have to remember that everything is written with an exponent of 1. We just, we don't write it down. It's just kind of like, when you have something like x, we don't write 1x. We just know the 1's there, okay? So that's kind of the same kind of concept there, okay? The rule that we just did here with negative exponents, I can't have that because I can't multiply 2 to itself negative 3 times. That's not possible, okay? So what I have to do is flip it. Now remember, we write everything over 1, we understand it's over 1, we just don't write it that way. So what I have to do is understand that fraction exists, and I have to flip it, okay? And when I flip it, it takes the exponent and it makes it positive. So I have to do that. Okay, and as we go through this chapter, you'll see different things that you do, and you're going to understand kind of the process to do this. Okay, but right now, the basic one here, flip it. And then what that tells me to do is go 1 over 2 times 2 times 2. Okay, which we know now as being 2 times 2 times 2 is 8. So that becomes 1 over 8. Okay. So the same thing with this next one. I understand it's written over a 1. So I'm going to flip it because I can't have a negative exponent. And when I flip it, it becomes positive. And now I can get that. Okay. So really important, like I said, that negative exponent rule is just going to be huge for us, okay? And 2, we're going to learn at some point when to flip it, because there's times when you don't want to flip it when it's negative, and we'll see it as we kind of go through some other sections, okay? So this last example, I know it's written over a 1, so I'm going to flip it, okay? And we just don't write things with a 1 exponent, so I get that, okay? So nothing to be scared of on that. I know that fractions, sometimes we get a little upset when we see them. Not a big deal here, just understand how to do it, okay? Taking the first rule that we did today, anything to the 0 power is 1, okay? Anything to the 0 power is 1. Okay, now the one exception is when you have this, and you're not ever really going to see this again, but 0 to the 0 power is undefined. Okay. Because if you go back, and I'll say, kind of explain why. It said every non-zero number raised to the power of 0 is 1. Okay. Well, that 0 is a 0 number, so, but the rule there is it's undefined. Okay. But I'm sure, I don't ever remember us doing that on a test or having on a test. You're going to see stuff like this, okay? So remember that, but this one right here is kind of the oddball thing, and I don't remember ever doing it again, okay? All right, moving on. We got these different ones depending on, zero exponent or a negative exponent, just got to remember your rule, okay? So why don't you go ahead and write these down, give these a shot on your own, and then you know, hit pause and then come back, hit play, and I'll have the solutions for you, okay? Okay, so it's a negative exponent. There's nothing else there, so I just understand I'm going to flip it, and I get this, okay? Remember, that's not 9 times 2, it's 9 times 9, so I get 1 over 81, okay? Once again, you know, I understand it's over 1, so I'm going to flip it. And when I do that, it changes the exponent to positive, and anything to the first power is really just itself. So we get that, okay? Once again, it's written, I understood it's over a 1, so I'm going to flip it. And I get this. Now, there's nothing there for me to do after that. Okay, so I'm just going to leave it as x to the third because I don't know what x is. Okay. All right. Understand it's over a 1, so flip it. Okay, so 2 to the 4th. Now remember, that's not 2 times 4. It's 2 times itself now 4 times. Okay. So remember that 2 times 2 is 4. 4 times 2 is 8, which we kind of already did, but now another one, 8 times 2 is 16. Okay? And I'll tell you when you have to simplify it. If I tell you just to fix it or simplify the exponents, you'll be fine. But if I want an answer like that, we will let you know which way to write it, okay? Sometimes this might be okay. All right? Anything to the 0 power is 1. So just taking those 2 rules that we had in notes and being able to apply it, okay? All right, now this gets a little bit difficult here, so really important that you maybe come back to this set of notes or these examples here and kind of look at them, right? Now this -2 here, okay, is not a -2 exponent to everything, it's just to the b. Okay, so you know, we understand it's written over 1, but I'm not flipping the whole thing, I'm only flipping what's negative, okay? And to kind of, before I get going here, if I flip the whole thing, this +3 would end up having to be switched to a negative exponent, and that puts us back into, I can't have that. So I just want to flip the one that's negative, okay? So you can also, you know, because you're multiplying it, you can split stuff up, okay? Math lets me do that because I'm still multiplying it, and you're multiplying all these things, okay? So which one am I going to flip? I'm only going to flip this one. Okay, so I flip the second one. I keep the first one as it is, but since I'm multiplying, I can multiply the tops together, and when I do that, I get 5a to the third. I multiply the bottoms together, I get that, okay? Now, I've showed you the long way to do this. That's not how I would typically do it. I just recognize that I'm going to flip the one thing that's got a negative exponent, and sometimes what I'll tell you to do is just move it down. Just take it and move it down to the bottom, which is basically what we got there. Okay, so I showed you kind of a long way. You know, you're going to learn how to kind of make some shortcuts or whatever, okay? So here on this one, kind of a cool problem because you got to be able to do this. It's negative, it can't be negative, and the rule said to switch it or flip it. So if I flip this, I'm really going to get this, and when I flip it, it, you know, magically is going to change the exponent to positive, okay? So you're going to get this, and you know, I need to rewrite that. That's really, this is more of the right answer right there, okay? So flipping it, either way, whether it's on top or it's on the bottom of a fraction, you flip it and it changes it, And no matter if this first one that we had, wherever it might be, I'm only flipping what's negative. And that -2 does not make the whole thing negative. Okay? Okay, if you could write down, we're going to do some substitution here for S and for T. And then if you can go ahead and write down the problem here. Okay. So this is a test question. You've got to make sure we can do this pretty good, all right? So if I take these values now and I substitute them in for S and T, I'm going to put them in parentheses, okay? So I've got 3, and then S becomes 2, and it's to the 3rd power, okay? T now becomes a -3, and it's to the -2 power, okay? So that's substituting, got to do that first. And then, you know, I'm on alert here because I got exponents, so I got to remember my exponent rules. In this case, I have one term here that's got a negative exponent, so I need to flip it or I'll move it down, okay? These are not negative. I'm going to leave them where they're at. So I'm going to get this, and I'm moving this one down below it. And when I do that, it changes the exponent to positive, okay? And I'd probably ask you to solve this one. Okay, so let's do this. This gives me, you know, I got the 3 to the 3rd. We did this a little while ago, means 2 times 2 times 2, which is 8. Okay. And this one, you got to remember your math rules. This says -3 times -3. Okay, now remember, a negative times a negative is positive, so that's going to get me 9. All right. On top, 3 times 8 is 24 over 9. And always, always, always reduce fractions when you can. Okay, so 3 goes into the top and the bottom, so I'm going to get 8 over 3. And we'll leave it like that. Okay. Okay. So on this problem 4, if you could write that down, this one's a little tricky. So we're going to kind of take this the long road too, and then you'll get a better hang of it as you do this. Okay. When you have this fraction 2 over 3, and you got an exponent on the outside and the fractions inside parentheses, I'm going to take this exponent and I'm going to apply it to both the top and the bottom. Okay, so that's kind of what it's telling you can do. You don't have to do this. I think after you do these a while, you kind of get the hang of it, but that's what it means for me to do. Okay, now I can't have negative exponents, so I need to flip it. Well, the top's negative and the bottom's negative, but if I move the top down and the bottom up, or flip it, it's going to change the exponent to positive. Okay? So that's a rule too that you'll come across. Actually, it's not a rule that is brand new. It's what we did earlier, but we're just kind of doing increasing steps on how to apply it. Okay? Now 3 to the 3rd does not mean 3 times 3. It means 3 times 3 times 3. So that's going to get me 9. Okay? I'm sorry. Time out. Just told you not to do that. I did it. 3 times 3 times 3 is 27. And 2 to the 3rd power means 2 times 2 times 2, which is 8. Okay. All right. And let me just kind of do this one because this one's a little bit different. I'm going to apply that negative exponent to the whole thing. This is a little bit different now, okay? But I'm going to do it to both the top and the bottom. Okay, now since that 3m is inside the parentheses, that -2 goes to everything in there, okay? So I'm going to keep it in parentheses, but I have to flip it. So when I flip it, it changes all the exponents. Oop, get rid of that. Hold on. Messed that one up too. Gotta slow down. Okay, now what that means is, watch this. It means I do this on the bottom, okay, which is something that you guys learn in, will learn in a different section, or you already did it because we did some pre-teaching. But 3 times 3 is 9, okay, and m times m is m squared, okay. A little bit different there. So this is a really good problem right here that you need to probably make sure you understand how to do that, okay. All right, so guys, in this particular chapter, there's a bunch of little rules, and we give you lots of work on these because these are pretty easy. These aren't really long, drawn out problems. These are pretty quick, 1-stepper, 2-stepper, and but really trying to focus on the rules and getting strong with the rules, okay? So make sure you do a really good job with the classwork, even though seems like a lot of problems. It doesn't take you a whole lot of time to get them done. But there's rules you got to apply, and you got to be careful how you do that, okay? All right, so make sure you get that done. If you got any questions, make sure you get a hold of us and we can help you out. And don't hesitate. Make sure you get this cleared up right away. Thanks.